All right, time to learn about our LCD screen. This will be a pivotal part about this unit. Also classes and objects, but here we're just talking about the physical part of it. First of all, I strongly recommend following these links and reading more about it. Read the notes. We'll go over it a bit here, but it takes a bit to understand. Look at your crystal ball diagram in the book. Once you understand how it all works, that makes things way better. So let's go through the pins one by one. I really love knowing how things work. So first pin we run into is the VSS pin right here, our first guy. That's just main ground. And then VDD, just another word for our plus 5 volt main power connection to it. Third pin in, we've got our contrast voltage. This lists it as VE, but our actual object has it as V0. And depending on what voltage you got here, between 0 and 5 volts determines the contrast of the screen. So you can make it super dark or super light, depending on how you do that. And we're going to use a potentiometer in our circuit diagram to control that. If you notice that, we've got our potentiometer, one pin's connected to the 5 volt rail, one's connected to ground, and so our middle pin will vary between 0 and 5 volts. And notice it's connected to our V0 pin. So there we are. After that one, we've got our register select. Register select is something that's going to be handled by the liquid crystal class for us. But if it's low, it's in instruction mode. And so it'll interpret these data pins as telling it what to do, move the cursor, clear the screen, do stuff. If it's high, so if this thing is set to 5 volts, it'll interpret this as a new character to draw on the screen. Actually, we're just using these 4 pins because we're using 4-bit communication rather than 8-bit, just so we don't use up all our pins on our Arduino. And besides, who has time to connect all those wires? So that's register select. It toggles between instruction mode when it's at ground state, where it interprets this stuff as stuff it should do, and character mode, where it interprets these ones and zeros as stuff it should draw. We've got this read-write pin, which we're just going to hook straight to ground. Ground puts this in write mode, so you send information from the Arduino to the LCD to tell it what to draw on the screen, which is usually how you use an LCD. So we're not even going to connect a wire, because the read mode, if we had it at 5 volts, this guy right here, I put in read mode, and that would mean our Arduino would be reading the contents of the screen from the LCD through the data wires, which we don't need to do. We put that information there. We told it to draw that stuff. We don't really care after we've drawn it. But you might for some applications. So that's what that does. And the enable pin, if you think about this, we could do all this without an Arduino. With push buttons, we could do a ton of this stuff. You could draw characters. It would be ridiculous and painful. But what the enable does is it says, do the next instructions. Let's say we've got our register select set, and our read-write pin set. So we want to give it instructions to clear the screen. And we set up our data pins to send the ones and zeros that say, clear the screen. To actually do that, we're going to take the enable pin, and normally it defaults to high, 5 volts. It's going to go to 0 volts for a sec, and then back up to 5 volts. And that tells the LCD to do whatever it is the other pins are telling it to do. So every time it goes from high to low to high again, it's do the stuff the other pins tell you to do. So kind of cool there. It's very important. Again, our liquid crystal class will handle all that for us. It'll happen faster than you can press a button. So lots of things can happen very quickly. All these guys are data pins on our thing right here. Oh, by the way, our enable pin is abbreviated with an E, and our read-write pin is RW. Our data pins are the D0 through D7, and they hold the ones and zeros, the 5 volts and 0 volts, that tell what our Arduino wants the LCD to do. Depending on if it's in instruction mode or character mode, it'll interpret those as either a command, do something, clear the screen, move the cursor, or draw something where the cursor's at, if it's in character mode. We're, again, only going to you can use all of them in 8-bit mode. So if we hooked up all of these guys and set up our liquid crystal using the appropriate constructor, we could do it in 8-bit mode, and it would be slightly faster to update the screen, but it's already faster than we need. So we're only going to use the last 4 here in 4-bit mode. The rest will just be left unconnected because we don't need them. And then the last thing's pretty easy. It's basically there's a big LED in the back of the screen that lights it up. It's a backlight. And all we're going to do is we're going to connect this guy to our positive rail. So this is this thing right here, it's abbreviated as A. It's our anode, it's our positive backlight connection. And notice we are connecting it to our 5-volt rail through a 220 ohm resistor so we don't burn it out, just like we're used to doing with normal LEDs. And then this guy right here, that's your cathode. It's abbreviated as K on here. It's the last one. And that's the negative or ground connection for your LED. And we're just going to connect that straight to ground. If we felt like moving this resistor, we could connect our anode straight to positive and have our cathode or negative connection go through the 220 resistor before it hits ground, and that would work just the same. And that is how it works. Yeah, we just got our anode and cathode that make our back screen light up. We got all our like data wires, our 4 data wires that we're using, hooked up to some pins in the Arduino. And it uses that to send the information for what to do or what to draw. With our read-write thing, we only want to write to the Arduino, so we just connect that to ground to force it to be in write mode. This guy right here is our enable. Our Arduino is going to handle all that with our liquid crystal object. It's connected to pin 11, and that'll just go from high to low to high again every time it wants the LCD to do something, draw a character, do a command, whatever. And then pin 12 we've got connected to the register select, so that'll just be constantly toggling between instructions or character mode, depending. And then we just got our main power connections. So that was a bit long, but hopefully now you understand it better. Thanks for watching.